Okay, now take a look at example 1. Construct a ladder diagram to control two-way lighting system. Lamp will be turned on if one from two switches or both switches turn on. There are start and stop push buttons. All push buttons are normally open contact. So we need to construct a ladder diagram for this problem. A systematic way to solve this example may start with listing all the I/O using I/O table. So before we're going to solve this issue, so we need to understand the problem. So assume that we have two levels. So we have two levels. So assume that we have stairs. Okay. And there are two switches. Okay, got two switches. So assume that this one, on the ground floor we have switch 1, and the top floor we have switch 2. If one of the switches or both of the switches will turn on the lamp, so we have the lamp. We have a lamp. Okay. And a person is going up. Okay, assume that we have a person that's going up the stairs. Okay. Pressing one of the switches or both of the switches will turn on the lamp, and all push buttons, which is the switch 1 and switch 2, all push buttons are normally open contact. So first we have to prepare the I/O list. Okay, prepare the I/O list. So we need to know what is the input, what is the output, and we got to assign the address. So input, output, and address. So assume that we have start push button. So we have start and stop push button. Okay, start and stop push button. So now we have start push button, stop push button, switch 1, and switch 2. We only have one output, which is L1. Okay, so this one is L1. So you can assign the address. So assume that we have address for start button is I 0.0, stop is I 0.1, switch 1 or switch push button S1, we have an address I 0.2, and push button 2 we have I 0.3, and the output, and obviously the output is assigned by address Q. You can give it, the address is 0.0. Okay, to have a better visualization of the control logic, it is very convenient to construct a table that shows relationship between respective input and the output. Okay, I'm going to construct a table for you. So this kind of table in digital electronics is also known as truth table. So we're going to construct a table. So we have the switch 1 and switch 2, and this is the output is L1. So if both of the switches is not pressed, which is logic 0. So light, which is L1, is off. If S1 is pressed, S2 is not pressed, L1 will be turned on. The light will turn on. Same goes to if S1 is off, S2 is turned on, or S2 is pressed, the light will be turned on. And finally, if we have both switches is pressed, light will turn on. So look at this table. It is obviously something to look like the OR logic. So in digital system, you know that OR logic means if one of the switches or both of the switches if are logic true, then the output is true. So now we're going to start our ladder diagram. So we're going to start with sketching the latching ladder for the network 1 for the start and stop push button. So network 1, so we have start, we have stop, so we have the output. So this is start, this is stop, and we have output. We can assign the internal memory bit for the output, which is M10.0. You can assign M20.0 or even 10.5, it's up to you. Because it is latching circuit, so we have to connect the output as the input to be M10.0. In fact, we have learned in our previous lesson that this kind of latching circuit we can make use of the SR flip-flop. So we can somehow write this one in terms of SR flip-flop. So alternative using SR, this is start, this is stop, so this is SR, this is S, this is R, so we have output. So our output is 10.0, and again, because it is SR flip-flop, we have to make one dummy output, which is 10.1. So this is, we call as the, could be a dummy. In this case, this is a dummy. In another example, could be another useful output. Okay, so we not have enough space here. So that is for network 1. So then we have network 2. So for network 2, we have switch 1 will turn on L1, or switch 2, or switch 2 will turn on L1 as well. But again, we have to make use this internal bit, so we have to put the internal bit here, which is this one is M10.0. Okay, pressing start push button will turn on, pressing start push button will turn on M10.0. So M10.0, this one will energize, will energize, and contact M10.0 will close. So M10.0 will close. When press S1 will turn on L1, okay, or press L2 will turn on L1 as well. Pressing both of the switch will also turn on L1. Okay,